At the top of your paper, please write lesson 1 and 2, dividing fractions. And today's date. Now, as you know in class, we've been working just with models for dividing fractions. And so far we've covered dividing fractions by a whole number and dividing whole numbers by a fraction. So what we're going to do in this video today is just go over those models because they are different and it's good to have a different view of what they look like. So we're going to start off with dividing a fraction by a whole number. So if I had a number like 3/4 divided by 3. Well, we've talked a lot in class how we can convert this division problem into a multiplication problem. So it's really good to know how to do that first. So we talked about how 3/4 would stay the same. And we want to do the opposite of division. So we're going to change it to multiplication. And remember that dot means multiplication. Then we know whole numbers always go over 1. So if we're going to do the opposite of division, we do the reciprocal of 3/1. Now the reciprocal is just a fancy way of saying that we're going to flip it over. When we find the reciprocal, we see that it's now 1/3 instead of 3/1. So this is the same problem. But to model this, we need to model the first fraction. So I would take 3/4 and I'm going to model this vertically, meaning my lines are going to be vertical. So I broke my picture up into 4 pieces, and then I need to shade 3 of them because my model says, my fraction says 3/4. So I have 3/4 there modeled. Then I need to break it up into 3 pieces because they're asking me to divide it by 3. So I'm going to break it up horizontally into 3 rows. 1, 2, and 3. Now if I want to know what one part of that would be, because I've broken up into 3, how much is just one piece going to be worth? I look at the top row and I see, okay, there's 1, 2, 3 shaded pieces. So my numerator, or my top number, is 3. Then I look to see how many boxes there are total. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And I can see that my total boxes gives me my denominator, or my bottom number. Now we know we always reduce, so it's as small as it can be. So I have to think, what number can go into 3 and 12? Well, I know 3 can fit into 3 1 time, and 3 can fit into 12 4 times. So my final answer is 1/4. Now we talked a lot about this with word problems. So if we had, excuse me, 3/4 a cup of frosting, and we needed to spread it amongst 3 desserts, how much would each dessert get? Well, we would see here's 1 dessert, 2 dessert, 3 desserts. So 1 dessert would get 3 out of the 12 pieces total. So that's just another way to think about it. Now today, we talked about dividing a whole number by a fraction. So if I had 4 and I wanted to divide it into 3/4 pieces. Well, I know first off, before I model it, I can change that into a multiplication problem. I know whole numbers always go over 1. And I'm going to start with that. 4/1, that stays the same. I find the opposite, so that is multiplying. And I find the reciprocal, which is 4/3. Now, to model this, I start off with 4 pieces. So here's 1, 2, 3, 4. Now if you notice, they're all separate because it's 4 whole pieces. Well, then they say break them up into 3/4. So I'm going to break up each one into fourths because that's what they want us to break it up into. Then I need to see how many groups of 3/4 do I have. So how many groups of 3/4 do I have? Well, I know here's a group of 3 out of 4, 3 out of 4 pieces. Here is a group of 3 out of 4 pieces. 1, 2, 3, there's 3 out of 4. There is 3 out of the 4. There's 3/4, and then I'm left with 1 piece. And I have to think, well, how many pieces was I looking for? I was looking for 3 to go in each piece. So I only have 1 left. I have 1 out of 3 that I was looking for to put into a whole piece. So now I can count how many whole groups of 3/4 could I find. I found 1, 2, 3, 4, 5. So I found 5 whole pieces and 1 out of the 3 I was looking to put into a group. So I can double check to see if that is correct. I can solve this problem and go, okay, 4 times 4, that is 16. 1 times 3, that is 3. And I had nothing to cross reduce. That's why I just multiplied straight across. And then I have to turn this back into a mixed number, and I can go, okay, 3 fits into 16 5 times, because 3 times 5 is 15. I'm left with 1 out of 3 left over. So my equation here gives me the same answer as my model. Okay, we have one last type to do. What if, I'm going to scooch this down a little bit. What if I just told you a word problem and I said that 10 cups is 2/3. So 10 cups is 2/3, and I'll try to break this off from the other one. But I want to know how much is there total. Well, I can think about it this way. I can make a tape diagram. And so I have 2/3, and I can even shade that in. Well, I know 10 cups is 2/3. I know that this together is 10 cups. Well, then I'd have to figure out how much is just 1 cup. Well, if 2 of them is 10, 10 divided by 2 is 5. So I would know that this would be 5 cups, and this would be 5 cups. And if these two are each 5 cups, this has to be 5 cups. So if I wanted to know what 3/3 was, or how much was there originally, I could go 5 plus 5 plus 5. There is 15 cups total. So those are the 3 different models we have talked about in the last 2 days. Make sure that you wrote down all of these notes and that you are ready for tomorrow. Have a great night.